Just before we get started, I want to say sorry to all of you in the US who tried to pre-order my book that's coming out in a couple of weeks. You should never have been able to pre-order from amazon.co.uk in the first place. That was an error on the publisher's part, and I'm really sorry about that. Don't worry though, there is a big announcement coming soon about my book over in North America, which I am very excited about. Hang tight though, until then you'll be able to get your hands on the book eventually, just like the UK people will in 2 weeks' time. But anyway, let's get on with this month's night sky news, and let's start, as always, by looking ahead to what we can see in the night sky in the next coming month. So I hope that most of you managed to spot some meteors in the Perseids meteor shower this month. I know I did. I was on holiday at midnight, still lying on the sunbed around the pool, but this time looking up at the sky, starbathing, if you will. And I managed to spot about 3 or 4 of them just before peak, sort of early August time, which was really good fun. If you did get any pictures of them wherever you saw them, please send them to me on Twitter or Instagram or whatever. Send them to me. I'd love to see them. So the very early morning of the 25th and 26th of August, very thin crescent moon is going to be ringed by a collection of stars that we know as the winter hexagon. All seasoned astronomers will know that the winter hexagon really is a solid fixture in northern hemisphere skies in the winter. And apparently now the end of August is the start of winter because it's just started to rise.
Winter is coming.
And as the months march on, it'll rise earlier and earlier so that we can see it earlier in the night. So that, by sort of December, January, in the evening sky, it's a very firm fixture. So the winter hexagon is made of 6 of the brightest stars in the winter sky. And with the crescent moon back smack in the middle of them, it should be really easy to spot which ones those are. So what I would suggest doing is start by finding Orion's belt, which will be really close to the moon. Go down from there until you hit one of Orion's feet, essentially Rigel. It's a very bright blue star. So from Rigel, you then want to follow the hexagon round. First of all, down to Sirius in the southwest, the dog star. Then you want to go up to Procyon. I have no idea if I'm pronouncing that correctly. We'll find out. From Procyon, head up to Pollux in Gemini, which is one of the twin stars, Castor and Pollux. From there, head over to Capella, which is the top of the hexagon. Back down to Aldebaran, which will be just above Orion. It's the sort of red star in the bull, Taurus, and then back down to Rigel will complete the winter hexagon. Then on the evenings of the 5th and 7th September, you again get to use the moon to spot things, but this time Jupiter and Saturn. So it's going to be in between Jupiter and Saturn on the sky. And it's going to start off as like a half moon and then move steadily across the sky and get bigger. And it'll move from Jupiter to Saturn over the evenings. So it's going to be really easy to spot them. Jupiter's going to be the brightest thing in the sky, sort of to the right of the moon, and then Saturn will be the next brightest thing to the left of the moon. You can't confuse them for Venus at this time because Venus is usually the brightest thing in the sky, but it's actually too close to the sun for us to see it at the minute. So if you look out on those evenings and you see those two bright, what look like stars next to the moon, know that you're actually seeing Jupiter and Saturn. Then on the 20th of September in the evening, we again get to use the moon to find something cool in the sky. It'll be just past full this time, but look for it, look just slightly above it, and you should find the Pleiades star cluster. So with the naked eye, this looks like a cluster of 6 to 8 stars, depending on how good your eyes are. But if you can get binoculars or a telescope on it, you'll see so much more. It kind of looks to me like a sort of mini plough or mini Big Dipper a little bit when you see it with the naked eye, and it's just a really nice thing to spot in the sky. Alright, so now we know what to look for this month in the night sky. Let's turn our gaze instead to what's been happening in space news this month. So there's a paper that came out at the end of July that actually made mainstream news. And thank you to all of you that actually sent me the story on Twitter, because it came out just as I filmed my video about why we can't see the center of the Milky Way from the northern hemisphere properly. And at the beginning of the video, I said, so the Milky Way is like a flat disk, which, according to this paper, I can no longer say, because what this paper found is actually that the Milky Way's galactic disk is slightly warped. Like, it's sort of weirdly shaped towards the edges. So how they've managed to figure that out is really interesting. What they've tried to do is make sort of a 3D map of stars in our Milky Way, which you think sounds pretty easy. You mark their positions in the sky, but what you don't have is very accurate distances to those stars. However, there is a very specific type of star that we can get accurate distances for, and they're called Cepheid variables. They're variable stars. They pulse in their brightness on some time scale. So they might pulse every day or so, or every 2 days. But what we know about these stars is that how much their brightness changes is directly proportional to their time scale of their pulsation. So how often they actually pulse, what we call their period of their pulsations. So if we can measure how often the star pulses, we know what its actual brightness is. And then what we do is we compare it with the apparent brightness that we observe on Earth. It will be dimmed because we're seeing it from very far away. And then we can work out, well, how far has that light traveled to dim that much? And so we know the distance to those stars. To do that though, you have to find these stars, which is a lot easier said than done, because you have to look for when things are actually changing in the sky. But there's a lot of things that change in the sky. Stuff moves on the sky, like planets and asteroids and comets in our own solar system. There's, supernova going off. There's different types of variable stars as well. So it's very difficult to find them. So before this paper came out, we actually only knew of just over 1,000 Cepheid variables in our galaxy, the Milky Way. And what they've managed to do here is actually conduct a specific search for these stars in an experiment that's actually looking for lots of different things. And they've managed to find 2,431 new Cepheid variables in the Milky Way to get accurate distances for them. That's more than double what we knew previously. So if you combine all those Cepheid variables and all the distances that you now have, you can get quite a cool map of stars in the Milky Way. And obviously you assume now that the Cepheid variables trace the rest of the stars in the galaxy, which is a reasonable assumption. They're not sort of a star that you find having formed in a very special conditions. You just find them where lots of other stars have also formed. So what they do with all this is make this map, and you can kind of see from the 3D map that it is slightly warped, but what really shows you that it's warped is when you plot the height above the disk, i.e. like the z-axis, if you've got like x, y, and then like z going upwards, with the radius in the galaxy outwards. And what they've also done is plot that sort of for how far round you are in the galaxy, an angle that they call phi. And they've shown that you can really see that it's not flat as you go further out in the galaxy. It does warp to these different heights above the disk at various different radii in the galaxy. So it's really interesting to see that with these Cepheids. And yes, they've assumed that they trace the rest of the star population, and hopefully we'll be able to confirm that when the results come out from the Gaia mission, which is observing something like 1 billion stars in our galaxy to get all of their proper motions and distances really accurately. So we'll have to wait and see if the Gaia results also find the same thing. So sticking in the Milky Way galaxy for now, but instead of the sort of stars around us, I want you to turn your attention to the supermassive black hole in the centre. Now, on May 13th this year, a group of astronomers were up using the telescopes on Mauna Kea in Hawaii, and they were using the Keck telescopes to observe the centre of the Milky Way in the infrared light. And the first image they got down at the beginning of the night, they were really confused because there was this massive bright point source of light in the centre where there shouldn't be a bright point source of light. They were really confused. They were like, oh, is that like the star that's going around the centre of the Milky Way, the really famous one that like loops around really quickly and proves that there's a black hole in the centre? And they were like, no, because that's over there in the image. So what is that? And they quickly realised that that was actually at the position where we think the black hole is at the centre of the Milky Way, which was intriguing. So they kept observing it over the next couple of hours, and they observed that bright point source fading away. What they'd observed there was variability in the amount of matter that the actual black hole in the central Milky Way was accreting towards it. So all active black holes that are currently growing in size and eating material, they have what we call an accretion disk around them of this material spiraling inwards towards the black hole. And because it's going so fast, that material then heats up, it starts to glow and give off X-rays and radio waves from various different other processes, and then also obviously infrared. And so that's what they'd spotted here. What they couldn't explain was why all of a sudden it was that much brighter. There presumably had been more matter that had fallen onto that accretion disk to increase that brightness so much, and then for it to dim again as well. They even pointed out that it was probably brighter than that before they actually started observing it, and they actually caught it when it was dimming back down again. But the brightness that they observed it at was 75 times brighter than it normally is. So the questions were, is the black hole at the centre of the Milky Way showing increased activity? And if it is, how long will this period of increased activity last? So these findings were finally published in a paper this month by Do and collaborators, and they tried to address all of these questions in the paper. The first one being, how likely was this variability as well? So I was chatting to one, and he said that one of the grad students, Zhuo Shen, actually went through 20 years worth of historic observations of the black hole at the centre of the Milky Way, trying to get up the brightness and the variability for it, and trying to determine, how likely was this sudden increase in brightness. And it was highly unlikely. They worked out that the probability that it would have this much variability in a single night was less than 0.3%. There's a couple of possibilities as to what could have caused this sudden increase in brightness. One of them is that it could be to do with that star at the very centre of the galaxy that takes like 10 years to orbit this black hole. It could be that material from that star has somehow been disturbed and ended up falling onto the black hole. Or some of you will remember that there was actually a very exciting time about 4 or 5 years ago when astronomers thought that a gas cloud was going to get accreted by this black hole. It was coming very, very close to the black hole. And it ended up being not that exciting. It just sort of was a little flyby of the gas, essentially. And it just kind of got a little bit disturbed by the gravity of the black hole, but it sort of then went on its way. And people were expecting sort of like fireworks and big variability and seeing the flare of this black hole. So what Do and his collaborators suggested was that actually that material could have been delayed in getting to the black hole, and we're only just now seeing that material fall in and be accreted by the black hole. But we will need to monitor this further, and so get lots of different observations across all the different wavelengths of light to try and figure out what was going on here and maybe if it's going to flare again, and try and figure out what process is responsible. Is it the star? Is it the gas cloud? Or is it something else entirely? But remember, exhaust all other possibilities before anybody even suggests that it's aliens. A little bit closer to home now, and the European Space Agency and the Russian Space Agency have a mission to Mars planned for next year, launch in something like July 2020. And it's going to be taking ESA's Rosalind Franklin rover to explore Mars, and then also the Russian Kazachok lander. To do that though, you obviously have to get them to the Martian surface somehow, which means facing the 7 minutes of hell that's been dubbed the sort of 7-minute descent through the Martian atmosphere, from the very top of the atmosphere to the surface. Any craft you put through that is going to heat up to immense temperatures. It's going to have huge forces on it, gravitational, air resistance, friction. It's going to be accelerated to incredibly high speeds. So somehow you have to make it survive that, but then also slow it down so that it can land very nicely on the surface. And so the way that people do that is with parachutes. So before you go, you have got to test those parachutes you're going to use to the nines to make sure that they are working. So that's what they were doing this month in Sweden, with sort of like a dummy weight to represent the rover and the lander. And they dropped it from something like 29 kilometers, about 18 miles up. And unfortunately, that test mass crashed into the surface at high speed. And it was because there was somehow a tear in the parachute when it deployed, and so it didn't provide enough drag to actually slow that test weight down, or the weight of the rover and the lander. And so if that had been the real mission, the rover and lander would have been completely lost. So it's very important that they figure out what is going wrong with these parachutes and what's causing them to tear on release, because they've only got another couple of tests planned for these parachutes coming up, and if they're not ready by the proposed launch date next year, they're going to have to wait until 2022, which is the next launch window when Earth and Mars are sort of positioned appropriately to sort of have a short journey to Mars. So here's hoping that they manage to figure out what's wrong before that time. And now a fun thing to finish on, all to do with Pluto, everyone's favourite dwarf planet. So before the New Horizons mission did the flyby back in 2015, the best image we had of Pluto was from the Hubble Space Telescope, and it left a lot to be desired, let's put it that way. So because it was so fuzzy, we didn't really know anything about the surface of Pluto, and not knowing anything about the surface of Pluto means you don't have to name anything on the surface of Pluto. But after the New Horizons mission, that all changed, because all of a sudden we had these super detailed images showing mountains and valleys and lake beds and all of these features that all of a sudden we needed to be able to refer to, so that people weren't getting confused that they were referring to the same features because they've been called various different things in different academic papers. And so this is where the IAU comes in, the International Astronomical Union. They are basically responsible for naming anything in space. They're responsible for keeping it standardized and making sure that everyone knows what everyone is talking about and that there is an actual system in place. So remember, if you're in store or online and you see anything claiming to be one of these kits where you can name a star after a loved one or a loved pet, whatever it might be, it is absolutely false. It will not be officially recognised at all. You haven't actually named the star, you're just wasting your money. It's essentially fraud, so please don't fall for it. So the IAU are sticklers for making sure that whatever you're naming, it makes sense in the context. So for example, on Mars, a lot of all of the features are named after something to do with war, because Mars was the Roman god of war. So it's anything to do with war in mythology, or even generals of wars on Earth as well. So Pluto was the god of the underworld in Roman mythology, pulled from the Greek, which is probably where you'll know the name better, of Hades.
Yes, Hades rules!
So the list of categories for Pluto includes names for the underworld from all of the world's mythologies, gods, goddesses and dwarfs associated with the underworld, heroes and other explorers of the underworld, writers associated with Pluto and the Kuiper Belt, and scientists and engineers associated with Pluto and the Kuiper Belt. And then also just general explorers on Earth as well, because sort of Pluto is seen as sort of the edge of sort of the explorable solar system, and so people who sort of push the boundary of exploration. So for example, we now have the Alcyonian Lake, which was a lake in Greek mythology, which was one of the entrances to the underworld. We also have Mwindo Fosse, which is an Angan hero from Congo who travelled to the underworld. We have Picard Mons, but not that Picard. He was a 20th century inventor known for his upper atmosphere balloon flights. Then we've got Wright Mons, which is a mountain named in honour of the Wright brothers, the first people to take the first flight in a plane. And then also the Simonelli crater, which is named after a Dutch astronomer who spent their life researching the formation of Pluto. What I love is they've also gone one step further, because Pluto also has 5 moons as well. One of those is Charon, which is kind of like the same size of Pluto, and actually they're in kind of like a binary orbit, which is one of the reasons that Pluto isn't really considered a planet anymore, because it hasn't cleared out its orbit, because it's sort of like 2 planets in a way. But they've also said, well, if you're going to name things on any of Pluto's moons, then they have to be named after these various things. So for example, if you're going to name something on Charon, it has to be named after either destinations and milestones of fictional space and other exploration, or fictional and mythological voyagers, travellers and explorers, or fictional and mythological vessels of space and other exploration. So I am now pushing to get Serenity Crater named on Charon.
I'm a leaf on the wind. Watch how I soar.
Similarly, Styx is named after river gods, Nyx is deities of the night, whatever they are. Kerberos, you've also got like dogs from literature, mythology and history. So I'm secretly hoping for like a hooch terror at some point. And then Hydra, legendary serpents and dragons. So if Mushu Mons doesn't exist already, it should.
Hey, don't look at me, I ain't biting no more butts.
IAU, hear me. I will campaign for this. This is the hill that I will die on. You need to calm down. Black hole flickering too loud. Because that makes sense, Becky. And it's going to take the European Rosalind Franklin rover to explore Mars, and then also Russia's Kvavatov. Kvavatov? I just made that up. Kazachok. But after the New Horizons mission, that all changed, because all of a sudden we had these super detailed images. Images? I have no idea what I just said, but I knew it wasn't right. Start again, Becky. And so this is where the International Astronomical So this is where the International Astronomical Union, why can I not say that? They are kind of like the police of all things names in the solar system. They're the only ones with the, not in the solar system, in the entire universe. Come on, Becky. Spider. Gross. I mean, it was tiny, but still. And it's essentially fraud. Like the IAU refers to it as charlatanry. 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 Why can't I pronounce charlatanry? I can't pronounce anything today. Charlatanry. Charlatanry. Charlotte and re. Charlatanry. I mean, the IAU have come out and essentially said it's charlatanry, like it's fraud. I've done it again. Oh no, I did it right that time. Charlatanry. Yay!